We now discuss the solution of a problem from the section Integral Calculus. The problem is related to the definite integrals. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the second shift. The given question is, if integral 0 to 2 in brackets root of 2x minus under the square root of 2x minus x square bracket close with respect to x is equal to integral 0 to 1 in brackets 1 minus under the square root of 1 minus y square minus y square by 2 bracket close with respect to y plus integral 1 to 2 in brackets 2 minus y square by 2 bracket close dy plus I, then I equals, we are given 4 options. Option A, option B, option C and option D. Right. In all these things, make an observation. In these options, the under the square root of 1 minus y square, the integral of that integral 0 to 1 is appearing in all the options. Therefore, we keep the integral 0 to 1 under the square root of 1 minus y square. Wherever it occurs, we keep it as it is. So, we are given an integral 0 to 2 is equal to the integral 0 to 1 of some integrand plus integral 1 to 2 some integrand plus I, where we have to find the I from these options A to D, and we make an observation in all these options under the square root of 1 minus y square is appearing. We now discuss the solution of the problem in detail. We first take left hand side LHS, that is integral 0 to 2 in brackets root of 2x minus root of 2x minus x square with respect to x. We separate them. Root 2 integral 0 to 2 x to the power of 1 by 2 dx minus integral 0 to 2 under the square root of this 2x minus x square we have written as 1 minus x minus 1 whole square. So, this is same as 2x minus x square is same as 1 minus x minus 1 whole square under the square root. Agreed. Now, for the evaluation of this one, we put x minus 1 is equal to y. Differentiating dx is equal to dy. Since this is a definite integral, what happens to the limits? When x is equal to 0, y will be minus 1, right? When x is 2 minus 1, y is 1. So, this integral now 0 to 2 now becomes integral minus 1 to plus 1. So, root 2. The integral of x to the power of 1 by 2 is x to the power of 3 by 2 by 3 by 2 to be evaluated between the limits x is equal to 0 to x is equal to 2. Now, minus this integral 0 to 2 now becomes integral minus 1 to plus 1 under the square root of 1 minus y square dy. Agreed. Now, we come here. Evaluation we will show you. Root 2 into 1 by 3 by 2 will become 2 by 3. Root 2 into 2 by 3. And for the upper limit, it is 2 power 3 by 2, that is 2 root 2. So, this is root 2 into 2 by 3 into root 2. For the lower limit, it is 0. Now, this minus, the integral minus 1 to plus 1 under the square root of 1 minus y square dy, we have written it as 2 times integral 0 to 1 under the square root of 1 minus y square dy. Why? The integrand, that is under the square root of 1 minus y square, is an even function. So, integral minus 1 to plus 1 will become 2 times integral 0 to 1. Agreed. And as I have already told you while seeing that question, and in every option this integral 0 to 1 under the square root of 1 minus y square dy was appearing. I told you that you retain that one wherever you get it. So we will keep it as it is, we will not evaluate that. And that is equal to simplified 8 by 3 minus 2 into integral 0 to 1 under the square root of 1 minus y square dy. That is LHS. In the next slide, we go for the right hand side. Right. And LHS we have already evaluated. Take the RHS. RHS integral 0 to 1, this one, separately you separate it. That is integral 0 to 1 of 1 minus integral 0 to 1 of root of 1 minus y square with respect to y minus integral y square by 2 plus integral 1 to 2 in brackets 2 minus y square by 2 with respect to y plus I. Integral 1 dy means integral dy, that is y, to be evaluated from 0 to 1. This, I told you that this integral we will always keep as it is, because in every option this was present. So now this is 1 by 2 into the integral of y square is y cube by 3 to be evaluated between the limits 0 to 1. And when integrated, this one 2y minus y cube by 6, 2 means 2y, y square by 2 when integrated it will be y cube by 2 into 3, that is 6, to be evaluated between the limits 1 to 2 plus 1. This when evaluated, this will be 1. This we keep it as it is, minus for the upper limit it is 1 by 2 into 1 by 3, 1 by 6. For the lower limit it is 0 plus this bracket 2 times for the upper limit 2 minus 1. For the lower limit minus 1. So 2 into y for the upper limit y limit 2, for the lower limit 1, it is 2 into 2 minus 1 minus 1 by 6 into, for the upper limit 2 cube 8, for the lower limit 1 cube 1 plus identity. Now 2 into 2 minus 1 means 2, this is 2 only, 2 minus 1 by 6 into 8 minus 1 means 7 by 6. So 2 minus 7 by 6. Take the LCM, you get 12 minus 7 by 6, that is 5 by 6. So this becomes 5 by 6. Now 1 minus of 1 by 6, that is also 5 by 6. So that is 5 by 6, 1 and minus 1. And this integral as it is, this bracket will be 5 by 6 plus identity. 5 by 6 plus 5 by 6 is 10 by 6, that is 5 by 3. So this is 5 by 3 minus integral 0 to 1 under the square root of 1 minus y square dy plus I. So now we have to find I. That's the question. So take the left hand side and the right hand side answer is this one, equate it. So we are given left hand side is equal to right hand side. So left hand side is 8 by 3 minus 2 times integral 0 to 1 under the square root of 1 minus y square dy is equal to right hand side is 5 by 3 minus integral 0 to 1 under the square root of 1 minus y square dy plus I. Now keep the I here, 8 by 3 minus 5 by 3, that is 8 minus 5, 3 by 3, that is 1. 1 minus 2 integral 0 to 1, and here this one when it comes to the left hand side it is plus integral 0 to 1. So this will be minus integral 0 to 1 under the square root of 1 minus y square dy, and this is already 1 minus. So I will be 1 minus integral 0 to 1 under the square root of 1 minus y square dy. So that's your answer. So let's look at our options. And our answer I is equal to 1 minus integral 0 to 1 under the square root of 1 minus y square dy appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem from the integral calculus, which is related to evaluation of definite integrals. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.